All right, welcome. This is the AP Physics Workbook Solutions. Here I'm going to cover 1.F, which is talking about constant velocity. Here's the scenario. Carlos places a constant motion vehicle, which is the cart that you see on your screen, on the ground and release it so that the vehicle travels down the hall at 5 meters per second for 10 seconds. Okay, here's the car. Now, scale and label the axes on the graph of the right to draw a velocity versus time graph for the constant motion for the first 10 seconds of its motion. Here you go. That's how time is our input. Our output is its velocity. So here, let me just label you some values. So this is 0. Our time going to be 1 second, 2 second, all the way to 10 for which it travels. Okay. And here is our velocity, 1 meters per second, 2 meters per second, 3 meters per second, 4 meters per second, and 5 meters per second. All right, so we know that for the 0 seconds, it starts where? Okay, it will go here at it has a speed of 5 meters per second. At 1 second, it is at 5 meters per second because again, it says it release 5 meters per second. 2 seconds, it's still traveling at 5 meters per second. 3 seconds, 5 meters per second. Seems like there is a constant velocity. Okay, and that's how it should look like if you connect all the dots. All right, because again, it's continuous because I am taking it at specific intervals. Okay, so here now we're going to look at the slope of the velocity versus time graph. We know that the slope here is what? Okay, we know that delta y is what? Delta y here is 0. There's no change in the y direction. And delta x is, let's say, from 0 to 10, it's just 10. But we know that slope is defined as delta y over delta x, in this case 0 over 10, which is just 0. So we would say it equals to 0. And what is the units for this? It has what? The top part, it is meters per second, and it is also meters per second. And we know that as in terms of acceleration. Why? Because, again, if you put this value, slope is equal to delta y, which is delta y. The change in velocity. The bottom is your change in x time. And the change in velocity divided by the change in time is defined by the acceleration. All right, so here it says that the constant motion vehicle travels 50 meters for the first 10 seconds. So here we would say distance is equal to 50 meters. And your time here is going to be 10 seconds. All right. So collecting some evidence about the physical meaning of the area under the curve that can be used to support the claim above. Using the equation for the area of a rectangle. Why do they use the area for a rectangle? Because this is a what? This shape that is taken is the area. So let me try to shade this as best I can. That's what they're referring to, okay? All right. So let's just draw it down here for you to get a better visualization. And we know that this was time, and the time was 10 seconds. All right. And the height here was 50 meters. Okay. Good. All right. So the area under the line of the velocity graph is equal to what? So length, the area is equal to what? Length times width. So in this case, it is so I had it right here, 5 times 10, which is just 50 meters. Okay. We also know this as your displacement of the vehicle. So we had that. Okay. 50 meters. Good. Okay. All right. So, oh, nope. Sorry. So this is 5. 5 times 10 is what? 50. So the area here is 50. That's what it's saying. Okay. Just take a look. Okay, 5 times 10 is 50. That's how far it travels. All right. So 5 times 10 gets you 50 meters. All right. The units, this you could call this as distance. Okay. It's also known as the displacement of the vehicle. So here the key idea is the area under the velocity time graph is the displacement. All right. Okay, the claim makes sense because it is moving with a constant motion. It is traveling at a velocity of 5 meters per second. And each second, it moves another 5 meters. After 2 seconds, it has, 10 meters, right? 5 plus 5 is 10. And at 3 seconds, it should be 15 because you add another 5 seconds. And the next one, it's after 5 seconds, it moves 25 meters, right? It's a constant, okay? So here, certain things that we can write here. That okay. So let me just do the distance, and here's the time. It starts here at 0, 0. Okay. And then at 1 second, it was at 5 meters. At 2 seconds, it was at 10 meters. At okay. At 3 second, it was at 15. So that's not good. Here, right? 4, 5, 20, 25. That's what it's saying. Okay? So this behaves, if you connect the lines, this behaves like y equal mx plus b. The y is your distance, because that's your output. Your m, which is your slope, which in this case, it's going to be our 5 meters per second, 5 meters per second, times your input. X is your input, so that is going to be our time, plus b, which is your starting distance. So there you could write it as like your y initial, if you would like. Okay? But that's how it would look like, right? The equation that you are going to see on your formula sheet that describes this, because you see how this is a linear line, it should look like, give me a second here, should look like this one. Okay, should be this one. It looks like that. All right. So this again looks like y equals mx plus b. They just rearranged it. All right. But there you go. All right. So that is all your solutions for 1F.